So what is exponential growth? Well, to answer that, let's take a look at an exponential function. Let's say we've got the function y is equal to 2 to the power of x. That's right, our variable here isn't the base anymore. Our variable is actually an exponent. When our variable is an exponent, we have an exponential function. But what I want to do is I want to take a look at what does this look like when we go to graph it. Well, let's create a table of values. So let's take a look at what our y equals when we substitute -4 in. So this will be 2 to the power of -4, which is equal to 1 over 2 to the power of 4, which will be 1 over 16. When we substitute -3 in, this will be 2 to the power of -3. It's equal to 1 over 2 to the power of 3, which is 1 over 9. So it's still a really small number. It's gotten a little bit larger, but it's still very close to 0. When we put -2 in, this will be 2 to the -2, which is equal to 1 over 2 squared, which is equal to 1 over 4. So a substantially bigger number than this, but still fairly small. It's still close to 0. When we put -1 in, that'll be 2 to the -1, which is 1 over 2 to the power of 1, or just a half. So once again, it's growing considerably from here, but still pretty close to 0. It's a half. When we put 2 to the power of 0 in, well, that's equal to 1. When we start putting these values in, 2 to the power of 1, well, that'll equal 2. When we put 2 to the power of 2 in, that'll equal 4. When we put 2 to the power of 3 in, that'll equal 8. And when we put 2 to the power of 4 in, that'll equal 16. So what you can see here is it started really small when it was a negative indice, and it stayed really, really close to 0 for quite some time until our exponent here became positive. Once it became positive, the growth started to increase rapidly. To get a better understanding of this, let's actually sketch the graph of these points now. So as I start putting these points in, at -4, it's really, really close to 0. It's not 0, but it's really, really close. At -3, it's still really, really close to 0. It's gotten larger, but still really close. At -2, it's about a quarter now. So it's still pretty close to 0, but it's about a quarter. -1, it's about a half. Still close to 0, but starting to move away from it. At 0, it's at 1. At 1, it's at 2. At 2, it's at 4. At 3, it's at 8. So you can start to see here it's growing quite rapidly. At 4, moves all the way up to 16. So if we're looking at the growth that's occurring here, it seems to be starting really close to 0. And as it starts to become into a positive indice, the growth of it starts to explode. Like that. And if we were to continue graphing it, this would continue exploding more and more and more. Now, exponential growth is one of the fastest growths that you can experience. And I always like to remember exponential growth with like populations and things like that. If we were to consider the growth of bacteria, that often grows exponentially. It can often double in quite a quick time period. So as you can see here, exponential growth grows really rapidly. And it occurs when we've got an exponent that is a variable.